Hello, my name is Brian Locke and I'm a maker from Ireland who mainly focuses on DIY IoT projects. Yesterday somebody tagged me in a tweet from Smarter Every Day where he's looking to build a LED sign that can be updated from a remote location. And when I saw this tweet, I thought it looks like it was written for me because I've done a lot of work with IoT projects, and these displays that you can see here, they're really similar to the ones he shows in the picture, and I've done a lot of work with them too. And finally, he signs off the tweet saying, does anyone know an easy and cost-effective solution for this? Easy and cost-effective, or I would say cheap, is like my motto when it comes to projects. I love doing things as simple as possible and for as cheap as possible. So this project is right up my wheelhouse. And I want to show you how easy it is to make something like this with just a couple of off-the-shelf components and then some wires and a little bit of code. And that's it. Let's take a look. The first thing you should do when you're starting a project like this is get a really good understanding of what the requirements are. And from the tweet, Destin doesn't go into too much detail, but I think we can kind of infer what is being asked for just by what's showing up in the pictures and then the text as well. So like the pictures clearly show these kind of scrolling LED signs. So it looks to me like he's looking for some text to be displayed on them. And we should be able to do that with those displays I showed earlier, no problem. The other thing is he does specify via a web interface for being updated, but I think that's probably just that it needs to be updated remotely because he specifies one person will be in Montana and the other one will be in Alabama. So we might be a little bit loose with that web interface part because it would complicate the project a lot. It would be still doable, there'd be no problem with it. But what I think is being asked for is a sign with a scrolling text that can be updated from a remote location. So the next thing you should do with a project is knock off the highest risk thing next. So what is the highest risk of going wrong with the project that could set you off? Now there's two major components to the project. There's the display, which we'll talk about in a second, and then there's the network part or the remote control part. And I'm going to start with these displays first because if the display isn't working out, we might need to change our approach, as in change how we do it. Like if these displays aren't high enough resolution and we need to change to something like a monitor, then how we do it would have to change. We'd need to control it with something else. So let's take a look at these displays. So these displays are made up of individual LEDs, so each white dot there is an RGB LED. So this one is a 64 by 32 one. And these displays are normally used in like football stadiums or something. So they're used as part of larger displays, and they've got connectors that are used to connect them all to each other to, produce one large image. But I think these will work really well for what Destin is looking for. They're physically quite large, they're nice and bright, so they should be visible even in pretty broad daylight or anything. And yeah, I think they just look pretty cool. The next thing that we need to look at is how we're going to power all this in terms of like, what are we going to use to control it? So we need something to be able to accept the input from Montana and update the display and also control the display. So we're going to need something that has network connectivity built in and is capable of driving these displays. So what I'm going to pick is this ESP32. So this is a microcontroller, so it would be similar to something like an Arduino, but it has Wi-Fi built in and is generally a lot more powerful. You might be more familiar with something like a Raspberry Pi, and they're a little bit different. So a Raspberry Pi is like a really small computer. Like it can, it has an operating system, has a monitor, you can plug keyboards and mice into it. It's almost exactly like a computer, but shrunk down. While microcontrollers such as the Arduino or the ESP32, they're more similar to like what's in your microwave. It has one job that you program to it, and it just does that job over and over and over again until you program it to do something else. So it's perfect for this because they're inexpensive. Like even the Raspberry Pi Zero, they're quite cheap too. The one with Wi-Fi, the Raspberry Pi Zero W, is about $9. but this one is about $5 delivered from AliExpress, or a little bit more if you want it delivered from America. But it doesn't need anything like an operating system, so you don't need to buy a micro SD card for it, and they're generally much lower powered, so it's nice and simple for these kind of projects. This ESP32 is just the one that I'm choosing because it's inexpensive, but there are other flavors available of it too. This one is from my friend in Australia, Sion, or Unexpected Maker. It's called the Tiny Pico. And this one is from Adafruit, based in New York. This is the Feather Huzzah 32. But these two have some features that we don't really need, like battery management, so we're just going to stick with the more simple one. Okay, so we've picked what we're going to use. We're going to use these displays, and we're going to use this ESP32. So the first thing that you want to do when you're starting out with a new board or a new project like this is you want to get a blink sketch working. So there's an LED built into this board, and what we want to do is just make sure that we can programmatically make it blink. So if you're a software developer, this is the same as a hello world. And if you're not a software developer, just to relate this to something, say you got a new oven, the first time you're going to use it probably isn't going to be the Thanksgiving turkey. So you don't want to be building this complicated project and then find out that you can't program the board at all, because then you don't know whether it's, your wiring with the project or if there's something wrong with the board. So you should always start simple and work from there. So we're going to be using the Arduino IDE to program this, and there's a couple of other things that you need to set up for the ESP32 specifically, but it's really straightforward. But what I'm going to do is I'm going to put instructions on the GitHub page for this project, and I'll link that in the description. So if you want to follow along with that, just follow those instructions and it'll be no problem. Okay, so I got my board plugged in here. You can see the power light is on, but there's a second LED that isn't blinking. So what we're going to do is just upload the blink sketch to it, and you can just go to File, Examples, and go right up to the top here, go to Basics, and there's a blink, and open that one up. And once you have the correct board selected in this drop down, you should just be able to program this, and this keyword LED blink built in should work to blink the LED. So to upload the sketch, I'm just clicking this upload button here, and it'll take a few seconds to compile and upload. Okay, so that's done uploading, and as you can see, there is a second LED that is now blinking. So that means that we can successfully program this board so we can move on to bigger and better things. Okay, so next thing we need to do is connect this ESP32 to one of these displays. And yes, we're going to start with just one of them, because again, if you run into a problem powering just one of them, you're definitely going to have issues with two. So you want to keep each step as simple as possible as you're progressing, just adding small parts every time so you know you're not running into bigger problems down the line. So unfortunately, it's not just as simple as dropping this in here and it connecting up. What you can use are wires like these, and I'll link to wiring instructions in the project like I talked about earlier. But what I've done is I've actually made myself a board that does make it almost as simple as that. So we just drop this in here, and then we drop the board in on top of that. And there we go. That's all the wiring wired up as per the wiring instructions that I'm linked to, but it's just done all simply. Now I do sell these boards on Tindy, and I am planning to get a few more stockists in the US pretty shortly, so keep an eye on that, and I'll keep the lists in the description updated. I just want to give a huge thanks to my GitHub sponsors for helping support videos like these, and also for helping support the libraries and software that I create. And as a thank you, I will be providing the board files for these boards for you to download and get manufactured yourself if you want. The final thing that we need to do is power the display. So that's using this connector here. And they actually ship with these wires, so you can use them too. So the plan is you plug one in there, and then you've got these two terminal blocks, and I'll provide a solution if you're not using one of these boards, but with my boards you can just drop them straight in here with a screwdriver and connect them to that, and then you can power the project either using this barrel jack, or if it's a really low current project like a scrolling text will be, you can use the USB, but you'd be much safer to use just a bigger 5-volt power supply here, and I'll link to a few of them in the description as well. Okay, so we have the display wired up, but we don't actually know is it wired correctly yet. So we want to test that first before we start writing our own code for it. So we're going to use a library called the I2s Matrix Library, and there'll be instructions for installing that in the project as well. And what we're going to do is these libraries ship with examples. So we're going to get one of their examples working first, because that's a good starting point. So one of the most simple examples that you can do with this one is the test shapes, I believe. Sometimes there's not a great way to know which is which, so you might just have to go through them, or sometimes maybe even you need to ask the author of the library or something. But yeah, test shapes is one of the nice simple ones. Okay, so my board uses the default pin, so this one should be okay to upload, and we'll just check that out now. So next we're going to move on to the scrolling text, because it doesn't matter if somebody can update it remotely. If the text doesn't scroll, we're going to have a problem, because you can't fit too much onto these displays at one time. So I actually wrote some code for this already, so just scrolling text across the center of one of these displays. So we're just going to take a quick look at that now. I'm not going to go into super detail, I'm just going to cover it really high level, but it's not too complicated if you're familiar with programming. Okay, so the first thing we have up here is just kind of setting up the display. This delay between animations is something we may want to change. So at the moment it's 25, and what that represents is 25 milliseconds. So what's going to happen is every 25 milliseconds the text is just going to shift 1 pixel to the left. And if you wanted to make the text go faster, you would reduce that number, because if it was every 10 milliseconds it would shift 1 pixel to the left even quicker. So we can also control which way it moves. So -1 is telling it to scroll left, but if we did 1, it would tell it to scroll right. Then we're just setting up the position on the screen. The text here I have as hello smarter every day, but we could change that to be whatever we want. Just defining a few colors. And then this is some screen initialization stuff. So the setup of an Arduino thing just gets called once right at the start of when you turn on your Arduino, and then it'll never get called again. And then the loop, what happens in the loop is it gets called basically constantly, so over and over and over again. So there's a little bit of code here, but nothing too much that we need to worry about. Basically, it's just checking has that 25 milliseconds elapsed, and if it has, it's shifting the text. And once the text is fully off screen, it's putting it back to the start again. So this thing will constantly scroll, but we could remove that feature by getting rid of this code if we wanted to. Okay, so we've got scrolling text appearing on one of the panels, but we need to hook up the second panel now as well. There's a small couple of configuration changes we need to make, but again, I'll leave detailed descriptions of how to do this in that README file on the GitHub project. Okay, from a wiring point of view, there's really nothing to this. The power wire that comes with the screen has a second connector on it, so you can just connect that in there. And then these displays also come with these ribbon cables, and what you can just do is, following the arrow, you can plug it into the output of the first one and into the input of the next one. And there we go, that's it wired up. Okay, so we've made the changes to the code and we've connected up the screen. So hopefully when we click upload here, it will just work. Fingers crossed. It would help if I plugged in the USB of the board, but yeah. So you can see the wiring is probably working okay. They're completely duplicated at the moment. That's expected since the code hasn't been uploaded yet. All right, so that looks pretty good. I would definitely 3D print something to attach the screens together better, but like this is just a proof of concept. So this should be aligned perfectly. You can see when I hold it together, it looks like one continuous display, but they're a little bit off the way they're currently set up, but yeah, I think that's fine. Okay, so we have our text scrolling across two screens and it looks really good. The next part is doing the remote control part, and this has no right to be as easy as it is, but it's actually really straightforward if we use the right stuff. So what I'm suggesting that we use is called Telegram Messenger. So Telegram is almost identical to WhatsApp, but it has a few extra features. And one of the things that you can do is create a bot. So a bot is just someone else that you can chat to, like another user, but you can programmatically control what happens when you send it a message. And I've created a library on the ESP32 where we can receive these messages. So the person in Montana will just open up Telegram and be able to send a message, and there will be a bot running on the ESP32 that's connected to this 2D display and will display whatever text has been sent to it. So let's jump into that. I'm set up to use the Telegram library, and again there'll be instructions on how to set it up. But the first thing you want to do again is look at these examples. So if we go down to examples, Universal Telegram Bot, go to ESP32. If we go to Echo Bot, that's a nice simple one that we can modify. I already have a bot token, so this is kind of like the key that says that authenticates your bot with Telegram. So when it gets a message from an ESP32 with this token, which I'm going to refresh, it will know that this is the correct bot that it should be coming from. I'll populate my Wi-Fi details in a second, but so what this example does is it basically just replies back to whatever message you send it. So this is a good one to get started. So it'll just prove that we can text the bot and it will reply back to us. Okay, so we have the code running on the ESP32 and now we need to test it. So I have a Smarter Everyday bot that I created earlier, so that's where that token came from. It literally takes about 20 seconds to set up a bot token, and you do it all in the client, so it's really straightforward. But yeah, so we can now type hello, we send the message, it goes up to Telegram, the ESP32 reads it, and now it has sent back hello. So it's actually pretty fast, it takes maybe a second or two. So now that we have that working, it's time to just basically marry the two sketches together that we already have. We have one that's receiving messages over the internet, and we've one that's displaying scrolling text. So if we just mush those two together, we should be finished. Okay, so I have both sketches combined here now, so hopefully we'll be able to upload it. I have thought of a potential problem though. We'll see does it impact. If it doesn't, we'll never mention it again, but I think it probably will. So I'm going to upload it now and we'll see how we get on. Okay, so it did upload, but exactly what I thought might happen is after happening. So when you see it stop like that, that's the point where it's going to Telegram to check for a new message. So that's not great. So there's a couple of ways we can get around this, or there's at least one where we check for messages less often. I'm not sure exactly what the requirements are in terms of how often you check, but say if there's a new message that hasn't been displayed, do you really want to fetch another message when there's still like 5 seconds left of this message to display? So that's one potential solution, and we can try that now. That should be pretty quick to implement, so let's do that. Okay, so now you'll see that it's scrolling correctly. That's because it's not checking Telegram every few seconds anymore. It only checks Telegram when the text has fully scrolled off the left-hand side of the screen. So you can see there's a bit of a blank when the message has stopped, so it's checking Telegram and then displaying the next message, but it does work. So as we can see here, if I type in new message and hit enter, you can see it pretty much showed up instantly. It was just really good timing with when I sent the message and when it actually appeared. So I'll wait till it'll be on screen here. I'll type in a new message, hi, and if we see, it'll display the message that it already had on screen, and then we'll swap out to this new hi message. I think that works out pretty well, because you would want to display the message that's on screen first. Like, you hardly would want to like cut off hi right there and then swap in something new. So yeah, I think that's okay. Without knowing the requirements further, that might do it. The other thing that's potentially possible, and I haven't tried it with this exact setup, is that the ESP32 has 2 cores, so that basically means it can do 2 different things at once. So it might be possible to control the scrolling of the text using one of the cores and then fetching of the data on the other core. I think it could be, but I haven't tried. But yeah, it's possible. Okay, so there's the project pretty much completed. I'm not sure if that's exactly what Denton was looking for, but just given the requirements that we were able to kind of figure out or whatever, it seems to fit the bill. It's a scrolling LED matrix display that can be updated remotely and yeah, from anywhere. And yeah, so for low cost or whatever, this project probably cost about $60 in total, and that includes my board, the retail price of my board, which isn't needed. You could just use the wires. It just makes it a little bit easier to hook up. But the panels are about $20 each, and then the ESP32 is about another $5, and that's basically it. It's been powered off a USB cable, so you could power it just off a regular phone cable or whatever, and yeah, as you can see, it's working away. Yeah, so that's basically it. Big thanks for you watching. Hopefully this has inspired some people, or if you want to build your own, the instructions are all there, and if you have any questions, feel free to ask. And yeah, thanks a lot for watching. I'll see you next time. Bye bye.